So the general rule for when you're dividing radicals is that it's actually the same rule as when you're multiplying. It's coefficient by coefficient. So coefficient divided by coefficient, radicand divided by radicand. But there's another part to it, which is rationalizing the denominator. And that's the part that we need to learn today. So if you look at this first one, 2 root 8 divided by root 2, it's just 2 root 4, because 8 divided by 2 is 4. And then simplify that, and what does that simplify to?
4.
Just 4, yeah. So 2 times 2, which is 4. That one's completely simplified. 4. You can't get any simpler than that, right? The second one, so part B, 12 divided by 4 is 3. And 6 divided by 3 is 2. So this comes out to 3 root 2. Can I simplify that? No. So that one's just going to stay like that. It doesn't get any simpler than 3 root 2. 2 doesn't have a perfect square factor, right? And that's one of the things that you need to look at when you're simplifying radicals, is whether the radicand has a perfect square factor or not. The last one here is a little bit different, and it's going to rely a little bit on what you know about fractions. We can do the 4 divided by 2. That's okay. That's just 2. But then when I have root 3 over root 6, well, I can't divide 3 evenly by 6, right? But I can divide 6 by 3. And that goes at 6 divided by 3 is 2. So this actually becomes a 2 on the bottom. It's like you're reducing that fraction. 3 over 6 is 1 over 2. So the 2's on the bottom. But that one in part C is actually not fully simplified. So that's why we need this other part, this rationalizing the denominator. This one, 2 over root 2, is not fully simplified. So even though we did the dividing and reducing and whatever, it's not done. Here's the problem. For a radical to be fully simplified, the radicand must contain no perfect square factors. You guys already know that, right? You can't have a perfect square factor in the radicand for it to be simplified. The radicand must have no fractions. You can't have a fraction inside the square root sign for it to be simplified. And no denominator can contain a radical. So that's the problem with this one that we just did, is that we have a radical in the denominator. And having a radical in the denominator means that it's not fully simplified. So we want to simplify 2 over root 2. The problem is that it has that radicand in the denominator. We need to get rid of it by changing root 2 into something else that's not a radical. And we are going to do it by multiplying. What do I have to multiply root 2 by to change it into something that's not a radical? So to change it into 2. Root 2. But it's not okay for me to just say, I'm going to multiply that denominator by root 2. Because then that would change the whole value of the expression. But like we just said, it is okay to multiply it by 1. Because multiplying something by 1 doesn't change its value. So I'm going to multiply it by 1, but the 1 that I'm going to multiply it by isn't going to look like a 1.
What?
What's it going to look like? Anybody know? 2, close. 2 over 2? Root 2 over root 2. Nice. So here's what we're going to do. We're going to take that expression that we're given, 2 over root 2, and multiply it by root 2 over root 2. It's okay to multiply it by root 2 over root 2, because what's root 2 over root 2 equal to?
1.
1. And if I multiply something by 1, it doesn't change its value. But what it is going to do, because of the 1 that I've chosen, it's going to change the way that it looks. And when we do that, I'm going to multiply. When I multiply fractions, it's numerator by numerator, denominator by denominator. So it's going to be 2 root 2 over
2.
root 4, right? Or 2. Yeah. So 2 times root 2 on the top, root 2 times root 2 on the bottom gives me this, which is equal to 2 root 2 over 2, which is actually equal to
4 root 2.
root 2. Those 2's can cancel out, right? And it's just equal to root 2.
2 divided by root 2 is root 2. That's so complicated.
2 divided by root 2 is actually equal to root 2. So for the second one here, we're going to multiply by root 5 over root 5. And that becomes 2 root 15 over root 25, or 2 root 15 over 5. The 2 and 5 don't have a common factor, so I can't simplify that further. The 15 doesn't have a perfect square factor, so that's actually done.